We were the nation's first aeronautical research center.
Civil aviation started here. The Wright brothers walked the halls here.
We tested every military aircraft during World War II.
We were there when Viking was developed, and we led the first landing on Mars.
The evolution of the space shuttle, all that design work was done here.
We've been in the business a long time, and in fact have solved a lot of the problems that got us to this point.
At Langley, we are NASA's lead for the Environmentally Responsible Aviation Program. One of our challenges is being able to move far more people and products and services to a lot more places, and doing so more efficiently and more environmentally friendly. So to do that, we need more types of aircraft. This includes unmanned aircraft. It also includes looking at rotorcraft. We're also looking at supersonic aircraft and enabling supersonic flight over land safely and quietly. We're working with the FAA and DoD to look at not only air traffic management, but looking at new flight patterns, including unmanned aircraft coming into the airspace system and doing that safely.
All spacecraft are aircraft too. So that is the merger between the aerodynamics and the space. The whole Earth to orbit part is where both aero and space live. Right now it takes a lot of people and a lot of care and human touch in order to ensure that a particular spacecraft doesn't wind up landing on top of a boulder. So we're working on the vision and the ranging systems associated with autonomous landings.
We get a lot of challenges, and often when we go and try and address those challenges, structures and materials are part of the solution. So a good example is the Space Launch System, or SLS, NASA's next rocket that is for heavy lift that will replace a space shuttle. And the current technology won't do the mission without a complete change of the materials and structures that are typically used to get beyond low Earth orbit in terms of space access. Automated manufacturing, net shapes, there's a lot less scrap. All this has now come together as a result of a lot of work that was done at this center in the past that went into airplane applications that now directly moves into applications on the space side.
Orion is NASA's next big thing. It's the next capsule that's going to bring us to the edge of space. It's going to bring us to new frontiers beyond where we've been before. Here at NASA Langley, we're testing some possible impact scenarios that may occur when Orion comes back to Earth. We look at things like, will it survive the response? How many Gs will the astronaut see? Will the heat shield stay intact? Will it flip over? Because we can't test every single scenario, we rely on computers to fill in the gaps between our test data.
If you send people to Mars with the technology right now, when they get back, their body's full of cancer because of radiation. There's a lot of analysis that's done here at Langley to show that in a radiation sort of environment that they in fact are protecting the people or the instruments.
The hardest problem we have with sending people to Mars or robots to Mars is getting through that Mars atmosphere. It's not that it's thick and hard to get to. The problem with the Mars atmosphere is so thin. What Langley's doing, they're taking their knowledge of the Mars atmosphere, their knowledge of entry, descent, and landing capabilities, and they're building a scenario where we go through a multi-stage entry profile, where the best technology for that area of the Mars atmosphere is utilized to slow the vehicle down. A lot of the work we do in remote sensing can be applied in utilizing the capabilities at Mars in the atmosphere.
We're working very hard to try to understand the way our climates are changing and how we can characterize and identify our atmosphere. So some of the projects that we're using to be able to acquire this type of data are things like SAGE 3, Calypso, the Ceres instruments, and we're really excited for some of the missions such as Tempo and Clario, which can help fill the gaps in our understanding in terms of the way our atmosphere works and how we can make better decisions to protect our planet.
At Langley, we're a research center. We're not about today, we're about tomorrow. How do we make tomorrow a better place to go?
I want to be here to make a difference.
The projects that we're doing can provide information that's valuable not only to the United States, but to the world.
It makes me proud to be a part of a family of researchers and engineers that are doing cutting-edge work all the way from concept to flight.
I think the attitude is we have a problem. It's a really intriguing problem, and we're going to solve it.